Hello, everyone. Welcome to Catalog and Cocktails. It's Wednesday once again, and we're coming to you live from Austin, Texas, presented by Data World. It's an honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. My name is Tim Gasper, longtime data nerd and product guy at Data World, joined by co host Juan Cicada.
Hey, Tim, how are you doing? I'm Juan Cicada. I'm principal scientist here at Data World. And hey, Wednesday, middle of the week, end of the day, and time to take a break and chat about data. And today we're going to go chat about a part of data that to the best of my knowledge, I think this is episode, 75, 76, and we have not touched this topic. And it's a topic of streaming data. And we have a very special guest who is Arjun Narayan, who is the CEO of Materialize. Arjun, how are you doing? Thanks for being here today.
Excellent. Thank you very much. I'm glad to be here.
Awesome. I mean, this is you're one of the best people to be able to hear talk about streaming data and real-time data. Really excited to get into that. But before we do, let's talk about our tell and toast. So what are we drinking and what are we toasting for?
You go first, do I go Arjun. First or I go first?
Go first.
I'm drinking a Negroni here. I've sort of explored a lot of cocktails, and at some point I started drinking Negronis, and I pretty much exclusively drink that as my drink of choice for the past few years. I think it's sort of part of the process of becoming an old man as you become resistant to change. And it's been a while since I've drunk a drink other than a Negroni.
That's awesome. I love Negronis, and there's a lot of good like Negroni adjacent cocktails, like very similar to Negronis. Right. So I love that. If you're gonna have a go-to cocktail, that's a good one. For me, it's an old fashioned. That's my go-to.
Close enough.
Same for me. How about you, Tim?
I'm drinking something new today. I always try to have a new cocktail for our episodes. This one is called a Greenpoint cocktail. Very similar to a Manhattan. It's in the sort of New York borough of, family. I guess there's a whole bunch of like offshoots of the Manhattan that are just different neighborhoods in New York. And this one has 2 ounces of rye and bitters like a normal Manhattan, but it has, instead of 1 ounce of vermouth, it's half an ounce of vermouth and half an ounce of yellow chartreuse. And I'm a big fan of yellow chartreuse. Very interesting flavor profile. So yeah, delicious cocktail.
What would it be?
So fun fact.
Sorry, go ahead.
I just live 10 minutes from Greenpoint, so I'm excited to. It's because I live in New York, in Brooklyn, not in Greenpoint, but Greenpoint adjacent, as you said.
Well, that's an awesome coincidence there. So you should try your neighborhood cocktail pretty soon.
I should.
Well, I'm curious what it would be if it would just be an ounce of chartreuse instead of half, and
That's a good question. I don't know. I'm going to start experimenting.
Well, I went into my bar today and I saw that a brand new bottle of Liquor 43, Licor de 43, which it's a Spanish liquor. And the traditional one is called the Carajillo, which is that Liquor 43 with a shot of espresso. But I was looking for something else, and just with sparkling water and some lime. This is super, super delicious. And I think it's super easy drinking that you got to be careful, but I'm really excited. And it's called Balón 43. So the 43 ball. And I was reading up. It's something that a lot of folks in the Netherlands drink a lot, apparently. So anyways, cheers. And, what are we toasting for?
Anything? Well, this would be a, cheesy toast, but I think these days, to world peace is, I think, not inappropriate.
Not cheesy at all for world peace.
Cheers to that.
Cheers to that. Well, so we got our warm-up question today, which I realize is kind of a tongue twister. Let me see it. A brook, a creek, or a river? I did it right. Which is the best stream and why?
That's a great question. I don't know the distinction between a brook and a creek. They both feel smaller than a stream. I'm gonna go with what I perceive to be the smallest, which is the creek. But I may be wrong. I don't know if the creeks. I think small streams are underrated. I think we go for big rivers and deltas and delta lakes, and they're cool. But the small streams are fun too.
I like that. It's not about just big data. It's large amounts of small water data.
That's right. That's how the river, the tributaries, that they feed the river.
I like that. Tim, you want to take the other position? You want?
Yeah, Arjun, I think you're wrong here. I think it's really about the river. I think we need to have a detailed discussion about this.
Well, how about we take the discussion a different way and let's kick it off with our honest, no BS here. So, um, I'll be very honest. I streaming data, real time data, that area of technology has not been something I've been paying attention to. I think that's a wrong thing for me. And I'm going to just be very selfish right now. I'm like, this is going to be my opportunity to go learn a lot about what's going on, talking directly to you. So honest, no BS. What do we mean by streaming data? What do we mean by real time data? What's the different? What is this? Kind of let's just start with there.
No, that's I think, the perfectly fair question. I think it's something that you're not the only one, and definitely streaming data is on the newer side in the data ecosystem. It's relatively recent that streaming data has even come mainstream. I think the easiest way to wrap your head around streaming data is in contrast to, or sort of first to talk about batch data. I think we all sort of get batch data. There is a data set, right? And there's lots of concerns and lots of details as to when that data set comes into being or how it comes into being. But typically we all understand the idea of there's a data set, we're going to run some analytics, we're going to get some value out of our data set, and there's all these concerns. And then we also have the sense of, we may have to repeat that job, right? So there was a data set at midnight last night. There's going to be a data set midnight tonight. It's going to be another one tomorrow. And streaming is really sort of generalizing that to sort of change by change. What if instead of once a day, we want once an hour? Why not once an hour, once a minute? Why not once a minute, once a second? Why not once per the smallest quantum of change in that data set, right? So if we were rerunning our and this would be wildly computationally inefficient, but what if we spun up our entire cluster conceptually, every single time there was the smallest change to our data and reran everything? That would give you this continuous real time updated whatever it was you were doing in your business, right? Be it analytics, be it machine learning, whatever the use case. Now, of course, you don't want to actually approach it that way, right? Like that's computationally insane. And streaming has been a way to get that real-time value, by going sort of one level deeper and talking about how you would actually tackle a problem of that nature, which is oftentimes you would work on the incremental changes. You would look at, okay, what is the change that is coming through? What is that event, right? You look at the delta rather than going snapshot to snapshot, right? So in the former batch world, you oftentimes think of your computation in terms of snapshot, and there's a lot powerful about that conceptual model, right? This was all the things that had happened as of yesterday at midnight, and we want to run some sets of computations on that. That's a great sort of mental model. It simplifies. In streaming, you're often thinking about the changes. You're thinking about, what is the discrete event that happened and how do I update the computation that I may have already done? Because it's not feasible for me to throw everything out and start over, just because one small thing in one corner of the data set changed. Right? So I think there's some amount of confusion because these models are just different. It's thinking about the changes as opposed to thinking about the totality of the data set. And oftentimes that gets but the reason people do that is because they want the same value that they're getting out of their batch computation on a more sort of frequent, real time, sort of close to the wire basis.
So that's a great explanation. And so when you're doing batch, that tends to be more like the paradigm I think a lot of like data warehouse, data lake type people are often familiar with, where you've got these jobs or these pipelines and they run on certain schedules. Maybe it's based on some sort of a trigger. Oftentimes it's based on a time. And a snapshot comes together or a calculation happens, or in some cases like a data mart is put together for a particular group to use, versus streaming is much more about like incremental, the deltas, how close can we get to sort of a real-time experience around it. Is that a pretty good summary?
I think that's a very good summary. And I think there's oftentimes a mismatch because in streaming, they're talking two things have changed. It's always difficult when you change a model twice, right? It's like it's easy to reason about a model you've changed once. So from batch, the thing we care about, and not everyone cares about, not every use case needs real time, right? Like it's just taking everything batch and making it real time is not necessarily the right answer here, right? You don't, There's many use cases. I think a substantial minority, call it, as spitballing here, 20% of use cases that would totally benefit from being up to date all the time. But we've changed that dimension, which is the real timiness, and but we've also changed the way we're actually going to express that computation. We're going to express it in terms of, or at least that's how traditionally the streaming ecosystem has talked about things. And now this is why you often see this mismatch between these two ecosystems, and they sort of lived in isolation of each other. I think the streaming folks often talk past the batch folks and vice versa.
Yeah, there's kind of two different paradigms and even two different sets of technologies. And just before we get more into the technology side of it, you had mentioned about use cases. I have a feeling that, we're going to talk a little bit more in this session today about, like, even though maybe 20% of use cases truly need real time, perhaps real time architectures are useful for more than just that 20%. But if you don't mind, like, what are some of, like, the prime examples of use cases? When people think streaming, they often think, these use cases.
Yeah. So, so let's take a Materialize user today, Drizzly, right? So Drizzly uses Materialize to power their notification system, right? So they've got all sorts of uh, data about the usage, about the actual transactions that are happening, and then you've got these, amazing analysts who so far have been working in a batch paradigm. They run queries and they go, well, these are the users that have really shown purchase intent, right? And we see this all across organizations. There's incredible analysts and data scientists who are sort of crunching data. And by the way, this is a wonderful task that you always want to do in batch, because when there's 14,000 variables, like, the last thing you want to do is add another variable of time, right? So you're trying to simplify things as much as possible to get to your insight. But the question then comes is, once you have that insight, oftentimes you'll realize that that insight is time sensitive, right? Like, you may realize, when we know this and this and this about a customer, we need to send them this coupon or this notification, right? And that is incredibly valuable in that first 10 minutes after that event happens. Implementing that requires, you can't implement that on your analytics stack, which is primed to run once a day. And a lot of what we do at Materialize is bridging this divide, right? Which is allowing people who have used and we can get into a little bit, but, like, I have some strong views as to, like, what this means. Wouldn't be a spoiler. It's a very SQL sort of forward viewpoint, which is, you got to, let people build streaming stuff with just SQL.
Mhm.
But taking that insight and building a production application that will have that sort of 10-minute or 1 minute, and we have some customers in the financial space, right? That for them, seconds is definitely in the trading financial space. They want to take action a sub-second or a single digit number of seconds. Putting that into production often today entails an entirely different technology stack. And folks definitely have been productive at using streaming data sort of on the wire, like building manual applications. But the proposition we have at Materialize is that you should be able to do it roughly the same way as you do it in batch, which is writing SQL queries and building these pipelines using the very same tools and technologies.
So the sequel aspect is I think is really crucial here. I think actually one of our next guests is gonna be Bob Muglia, and I know Bob says sequel always wins. So I'm with him on that, right? I think
I'm with him 100%. I may have drunk too much Bob Muglia Kool-Aid, right?
but I mean, historically, I see it too. It's not just drinking Bob Muglia Kool-Aid. It's just, you look at history, right? SQL comes up and down. It's always there, while other technologies go up and down.
Right.
But let's without getting too salesy here. I want to really understand more kind of the landscape of all the tools, technologies out there when it comes to streaming in real time, right? Kafka, Kinesis. I mean, there's Materialize, there's a Confluent, and there's more. What's the history of this, and where is the market going?
Oh, this is a great question. I mean, stop me if I'm going on for too long, right? So, like, I really think of the streaming event-based architectures, as these go all the way back to like the late 90s with the first with Tibco, which was the first sort of enterprise message bus, right? Like you could send stuff in real
ESB,
time.
MuleSoft, and
And
all that
the
stuff.
So that came
CEPs
later,
and
right?
all
So
that, right? Yeah.
I think I I believe, although I can't, I'm not going to claim with absolute certainty that Tibco was the first one. So Tibco
Okay.
in the mid 90s, you could essentially build these publishers and these subscribers, right? So publishers could fire off events to the service bus, and you'd have consumers that would consume these things. Now, the problem with these architectures, the promise of these architectures was always this allows you to decouple the producers from the service from the consumers, and the reality was that was never the case, right? Because a good way to think about it is, if the producer is going to change the schema, like the consumer is going to break the moment that schema changes. And so now you got to call a meeting, and everyone's got to sort of, like the Indiana Jones, Raiders of the Lost Ark, it's got to like replace the idol with the bag of sand, like exactly at the right point. And now you've got a giant meeting with a bunch of stakeholders. We're all going to fight with each other, and
But
nothing's going
that
to get
still
done, right?
happens
Like,
today, anyways, right? I mean,
totally, but I think, so I'll always say at least one positive thing about every single technology I talk about, right? So like I think the best thing that Kafka did was it allowed producers and consumers for the first time to most of the time decouple, because Kafka is a message bus that has, or at least has, the API of having infinite storage. Of course, there's some poor SRE over there who really is to ensure that the storage is presented as infinite, right? But because Kafka was the first storage bus that allowed you to basically keep buffering without just sort of falling over. Before Kafka, the brokers essentially had no or a very small buffer, and so if a producer changed something, then the consumer had to change something like right then. Kafka allowed you to sort of decouple that. But it didn't really solve many of these other problems, like specifying your computations, right? And so we have lots of frameworks. You've got Kafka Streams, which is essentially a framework for you to write programs that would consume, to write and to orchestrate these programs that would consume these um, um, events directly from the bus and do some computation. You have to worry about, restarts and distributed systems and I'm not the first one to make this observation, but the last place you want to be is reinventing all the hard parts of a database, like on your own. You have to worry about consistency. You have to worry about partitions. You have to worry about restarts. You have to worry about exactly once. Like, this is not easy, right? Like
Mhm.
this is incredibly hard, and it's a big reason why even those of us who like to nerd out about databases like don't want to do it in when under resourced and under budgeted, when we're actually trying to achieve something else, some other
yep.
business objective. Um, and that's where, even though it's been this hard, I think that's where a lot of the streaming ecosystem is, right? So you have Flink, it's a stream processor. You have Kafka Streams, it's a stream processor. You've got message buses you can use, Kafka, Kinesis, right? So Kinesis is Amazon's sort of managed message bus that sort of, I guess, competes head to head with Kafka, but Kafka sort of has this whole suite of this much more rich ecosystem of Kafka Streams, and then KSQL DB, which is their SQL-like layer for building these Kafka Streams programs and executing them on top of Kafka. And we at Materialize also sit in this ecosystem, right? So we are message bus agnostic, right? You feed us the data however you want. Be it Kafka is the most popular sort of message broker out there, so it tends to be the one that. But we're sort of agnostic as to how you would feed us data. But we have a provocative take, right? And our provocative take is only SQL. Right? You get to only write standard SQL to describe programs that will consume these events, and these will be exposed to users as views. So that now I'll be the first one to admit that this is a subset of programs. You can't write all the programs. Like in Flink or in Kafka Streams, you can write an arbitrary program. That's super powerful. It's also a curse, right? Like 99% of the time, you don't want to write an arbitrary program. You want a precise, piece of business logic, ideally, expressed in standard SQL, not some, subset of SQL or some SQL like syntax, in standard SQL. And 99% of the time, that's the cleanest way for you to express your computation, which frees you up to really go to town building a beautiful distributed microservice for that last 1%. Right? You don't want 100 microservices. You want 3 microservices and 297 views. That's sort of our take. And that's what we've been focusing on building at Materialize.
That is really, really interesting. And I love the way you've kind of tied this into the overall history of how things have evolved. Is it fair to say that, like, when you're thinking of things like Kafka, oftentimes you're thinking in the paradigm of topics and how those topics kind of interact with each other with sources and things and syncs and things like that, right? Is the core paradigm therefore in the Materialize world something like the view and how these views hang together?
Yes, you put it better than I did, certainly. Yes, the core paradigm is the view, and the underlying stream processing is the implementation detail and how we're going to keep the view updated. You as the user simply want to think of your logic in terms of this declarative, page of SQL, be 1 line or 30 lines or 300 lines of SQL. Could be, neatly encapsulated, maybe views stacked on views that read from other views, that join other views. You can have this beautiful little directed acyclic graph of computation built up, but it's nice, it's declarative, it's clean, it's got a clean schema. And you don't actually want to, at the same time, have to worry about all the implementation complexities of how to do the incremental computation for every possible set of input that it could be an update, could be a delete, could be an insert, could be way too many inserts. These are implementation details, and so far users in the stream processing ecosystem have been forced to deal with this. And our view is, what's the possibilities for streaming if users can think about the business logic?
So okay, let me kind of rephrase this. And my understanding here is, for all the streaming, all the tools that you've talked about in the history of this is to be able to go deal with, as we've defined before, data that is very continuous, that you want to be able, I really love this use case, right? You have notifications and you want to be able to, you need to make an action and after a particular event occurs. I mean, that's something you want to have, that real-time information right there. So you can think about it as that there's existing tools or systems that enable you to go deal with this, but you're probably at a much lower level. And ideally, I think kind of your perspective is that we should be thinking about this at a more higher level, at a higher level abstraction, which is, I mean, that's how databases work, right? You write a query, say A join B. You don't think about, well, A has to be joined with B in that direction. You have to use this join algorithm, a hash join versus a merge join or whatever. Like, you don't ever think about it. You just say A join B, and the optimizer does all that work, does all the compiling. So we should be able to have that same level right now when it comes to streaming real-time data. And it seems, from what my takeaway is, that kind of current systems today, or up to now, I've been focusing kind of, if you're going to work with streaming real-time data, you have to go focus more kind of at the lower level. And the idea is that you want to be able to go do things kind of at a higher abstracted level. And that's kind of where you guys are going.
Yes, that's exactly right.
Okay. So go ahead.
No, I have an example that's, but I don't know if we want to sort of go down that path.
I do want to go touch on something else related here, which is we have to talk about DBT now. So DBT, all these, I mean, at the end of the day, you're talking about views, and views are queries, queries are rules, rules are mappings, map transformations. Is all the same stuff. They're just rules, first order logic, right? Source to target. But then what's the relationship between all of this and DBT and these batch transforms and what you're talking here? What's that relationship?
So I think DBT is emerging, or has emerged as the best way to model all your transforms and really do full lifecycle management of sort of, your pipelines, which may involve a sequence of transforms that may actually have to cross multiple stakeholders and before resulting in some sort of final product. that is consumable by a human. We think DBT is by far the best way to manage all of these complexities. A lot of people's first use of DBT, or how they often adopt it, is often to just like almost like a cron job, right? Like, I mean, that's totally super valuable to just like be like, this is the defined pipeline that I want to run all the time. And then the first reaction to Materialize is like, why would you need DBT if Materialize is going to maintain the pipeline, keep it up to date, and sort of do the underlying? And I think they're actually missing most of the value of DBT. I mean, DBT, well, certainly you can hit the rerun pipeline button, and that's some amount of value it delivers, but it delivers all this other value for testing, deployment, sort of evolving schemas, evolving business logic, and all of that still applies even in streaming, right? And in fact, it helps to separate these concerns of um, version controlling, doing sort of integration testing, schema evolution with DBT, and absolutely that carries over to streaming as well. In fact, I think I don't have the exact numbers, but a very large fraction, perhaps even the majority of our users and customers, use DBT with Materialize, and it's a very high fraction. And we actually, I think soon we'll go to a world where that'll be the dominant fraction of any really sort of analytic SQL anywhere, sort of managed by DBT.
No, that's awesome. I mean, definitely, as we've been talking to guests on Catalog and Cocktails, Juan and I have been noticing that a lot of companies are starting to leverage DBT as one of the core aspects of how they're managing those transformations as code, as part of really a robust process with declarative SQL, right? So you're using sort of logic that's very repeatable and understandable. And it's even on the vendor side, like folks like Fivetran, for example, have been on the show, and they're obviously taking a really strong approach to incorporating DBT. And it sounds like y'all are doing a lot of that as well, or at least your customers are. Do you see that this persona of the analytics engineer, whether literally or the hat, right, is going to start to become more of the dominant user to build logic on streaming as well? Um, or do you see that that's a little bit like sometimes, but there's still a really strong reason why you've got your data engineer, your data developer who's going to be doing more of the streaming stuff?
No, that's a great question. I think definitely we would like streaming to be as easy as possible and be the dominant way in which analytics engineers put their insights into production. Right. So now, whether that happens because the analytics engineers themselves personally do it, or whether it is because they hand it off to data engineers to do a little bit more sort of implementation, remains to be seen. I'm optimistic that sort of we certainly want to build a tool that the analytics engineers can deploy themselves. I think that's the best case scenario is the people who have the insights can put it into production as seamlessly as possible.
So one of the many of the conversations we've been having here on the show has been about the modern data stack, and I think we had a conversation with Nick Schrock about kind of defining what the core modern data stack looks like and where you go evolving. Right, there's all these tools now, and we kind of the conclusion is that the smallest thing you should start off with is you have like reporting. I need to do some counting of things, and you want to have an ETL, right? You want to have your ENL systems, your T for DBT, and some computation storage like a Snowflake or a Databricks, and then some reporting, analytics, and Tableau, whatever. That's the core right there. And then once you get that, you start saying, well, what's next? Do I need to start pushing data into other applications? And this is where the whole reverse ETL or operational stuff comes happen. And then I'm increasing more. You got et cetera, right? Your core modern data stack starts small and it gets expanding depending on your use cases. Where does streaming fit into all of this? What is the relationship between where does streaming fit within the modern data stack?
That's a great question. I think right when you want to take those insights and productionize them. So absolutely all the things you have talked about, which is just putting the data gathering in place, putting the basic analytics function in place, are all very important prerequisites, because until you have some basic understanding of what data you even have, you've done some basic sort of reporting, or sort of somebody stared at the outputs and saying, oh goodness, like this thing is a thing we should be acting on, right? So all of these things are feeding a human, right? So there's some human at the end of it that is going to look at these reports and think, right? It is the next step where you decide to do automated actioning, which is when streaming that's when time starts to matter, right? So the reality is, if there's a report or an email or something that gets triggered off that somebody internal to the company is looking at, time's not that important. Like, it's frustrating that it takes a couple hours. Yes, it's frustrating. It may take once a day, but humans don't change their behavior strategically minute to minute, right? It's when you start to have the system or the company act on an automated fashion that time starts to really matter, right? And you could do this with reverse ETL, and there's certainly certain cases where reverse ETL is a useful way to do it, but there's a lot of use cases where that's not fast enough because the data warehouse introduces so much latency to the job that the value of the insight is lost. The notifications is an excellent use case, right? So the notifications that you might want to send may have maximal value and acted upon as soon as the event happens or sort of shortly thereafter. That's when you want to take this pipeline and put it into a real-time stack. Now, our hope is this should be so easy that that very same DBT model that you ran should be translatable, sort of almost with no code changes, to a system like Materialize, because it's SQL, it's standard SQL, connects to many of the same EL tools, that you can go from batch to streaming with just SQL and no code changes.
Okay, so let me see if I got this right here, because this was an interesting insight. We start with the core of the modern data stack, and which is like do some basic reporting, counting, whatever. That's going to generate some insight for a human. And at that moment, the human doesn't need real time. I look at it today, I look at it tomorrow, it's fine. Once I generate that insight, we realize, oh, look, we need to be giving out coupon codes for people who do this or that, or we hypothesize that if this is, let's go test that out. And that has a real time implication, right? Once that insight has been generated by humans, right, after looking at some stuff and a decision has been made to go do something, an action that needs to be completely automated, that's where streaming would probably come in.
Yes.
So that means that, would it be safe to say that if you're thinking about it in the modern data stack, you start with this core, and then it's when we want to go automate the actions after an insight, that's the position where streaming would come in.
Yes.
All right. That was a very key takeaway. Tim, you have something to follow up with.
Yeah, I'm thinking on my side, and so, one of the things that I'm trying to navigate is that, and Arjun, I'm curious about your perspective on this. So I used to be pretty steeped in the sort of the big data realm, right? Cloudera, Hortonworks, Storm, and Spark, that sort of thing, right? And although I don't focus on it as much recently, certainly try to keep up with things. And there's been sort of this architectural paradigm shift that has happened over time, where at first it was like, wow, batch, this is amazing, we can do things at massive scale, and it was like, okay, well, just kidding, let's change it to be SQL based, and and let's make it as interactive in real time as possible. So it was like, okay, well, we kind of switched gears there, and then we started to talk about, like, well, how can we have these paradigms actually fit together, right? And so you had like the Lambda architecture, right, where it was like, oh, well, maybe we can have the streaming stuff go one way, and we can have the batch stuff go another way, and as long as we can like have the ability to reconcile these two things, then we can have the best of both worlds, right? And even though there's been some success stories in the industry of being able to do that, there's also been a lot of chaotic failures related to that kind of architecture as well, right? Where you start spooling a bunch of data that you can't reconcile, or you end up doing these real time things, and the batch jobs can't keep up, et cetera, et cetera. When you have this new world that we're starting to move into, that it seems like we're settling into, right? You've got sort of like the lake house or the warehouse. You've got DBT. You've got some of your modern tooling that you're developing around that, some of the modern ETL tools. And then you've got something like Materialize or some of the streaming paradigms. Do you see that there's a new architecture forming here where, things like Materialize, are always kind of maybe on the front end, kind of being this real-time buffer that shoots off to the real-time applications, and then it continues to move downstream to batch? Do you see like an interaction paradigm where, well, maybe things go into the batch system, but then like when you need to do fast lookups and stuff like that, then you've got your streaming database there? Is it all of the above? So kind of curious about like how are architectural paradigms shifting from your perspective?
So the my view is that the EL will move to real time because it's essentially most of the modern EL tooling is change based already, right? So
Mhm.
take Fivetran, right? It's a change data capture based EL tool. And those latencies are just going to go down over time, and that'll become, vendors will compete as to sort of how low that latency gets. And particularly in a change data capture based architecture, there's no benefits, or it's basically the same amount of work. It's just a question of when you do the work. Like, you're getting the changes in real time. Are you going to batch them up, um, and then send them in sort of smaller
Yeah.
batches?
So
But
my real time is once a day. That that's the batch, right? That's the EL today is real. The E and the
so
L
so
is a real time of once a day. Sorry.
So the E is today oftentimes real time, and the L is once a day, mostly because traditional data warehouse architectures don't want to do reindexing, right? So the way sort of these modern SQL data warehouses are built is there's a fixed cost to the load process. So they often, behind the scenes are telling the EL vendors, "Hey, slow down. Like, it costs us money every time you load things. Can you give it to us once every hour? Can you give us once every 30 minutes?" But from the EL provider's standpoint, they're happy to feed it at whatever speed you want, up to some reasonable limit. And of course, a lot of people are loading from Kafka into Snowflake because they've standardized on Kafka as the data movement layer, and as we all know, Kafka is milliseconds, tens of milliseconds latency sort of data movement layer. If you have a Kafka loader appliance that sort of waits, buffers up for an hour, and then loads it up, that's mostly because the downstream consumer, which is usually a data warehouse, is sort of telling you to back off as much as possible. So I think the EL is going real time to an approximation, no matter what.
Mhm.
And you're going to have a batch and a real time system sitting side by side. The real time systems like Materialize consuming directly off the pipe, the batch sort of batching it up, and then and the humans are going to look at the batch because it's just easier, cleaner. It's more optimized for sort of interactive questions. And when you have defined workflows, particularly that are in the automated pipeline or directly interacting with a user, are going to be in the street running on a streaming provider. And the world I want to get to is all of these are defined using a set of shared DBT models. So the DBT models, there's a lot of them that are in batch for internal use, and then some of these internal uses evolve into modifications or improvements to the core business itself. And the ideal, I think the utopian workflow is click, 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 move from batch to streaming, and you don't actually have to worry about anything apart from sort of which provider is servicing that job.
So I kind of hear you saying that it's definitely shifting where the E and the L is going to become more real time, and the more interchangeable the logic is between the batch paradigm and the streaming paradigm, the more flexibility that we're going to have, where certain questions just make sense to ask in that batch paradigm, especially these sort of exploratory analytics and things like that, where you want to kind of have that snapshot of the world that you're kind of interacting with at that given time, right? Versus these real-time use cases, whether it's alerts or recommendations or certain real-time dashboards and things like that, where now you want to be able to have that same logic. And so these two worlds are going to kind of be like, well, what makes sense for what you're doing right now? and maybe you want to move that slider in one direction, maybe you want to move it in the other. But this is kind of the world we're moving to here.
So let me rephrase this kind of in my world, or
Yeah, sure.
my view of this is we will want to have things like DBT, and I would add to that. I think DBT also announced it's more kind of going into that semantic layer, right? That's the conceptual, logical part. We have those definitions of what are the main concepts, the main things that we keep track with in our business, and at the end of the day, the streaming, these, I guess, these EL vendors, but these ETL vendors, all these tools should just be one, and you decide, I want to go apply this transform or this logic from that represents this thing in the semantic layer, and be given this use case. Well, I want it to be streaming and to be batch. And then for this one, I only care about streaming. For this stuff, it's only batch. And really the winner here is going to be, I can do everything you want. You can real time it from once a day to once an hour to once a minute to once everything, right? Whatever you want. You have that variety with there. And then you're also connected it to a semantic layer. All these transforms, all this logic, the business logic is also contained. That's all in code. And at the end of the day, it doesn't matter if you are using a Tableau that's the user is interacting with whatever tool, they get the same data. Doesn't matter if they need it, if they're requiring once a day, perfect. If there's an application, a code that is generating, setting coupons to my cell phone whenever I walk close to a store, they know who I am, right? I'm the right person they should be sending it to. And that's also that logic, that the semantics of stuff comes from that semantic layer, the transforms, and the implementation of how that gets to me, to either to the application, to the user in the BI tool, whatever, depending on how you set that up. You wanted that in batch, you wanted that in real time. And the real winner will be in this ecosystem is a vendor, I guess, that can do both the batch and the real time.
So what there I props to you is that you really want the user to be able to pick and choose the vendor so that they can get the best vendor for that specific pipeline, right? So this way the vendors have to compete on cost, on price, on functionality, on,
so will we have vendors? Will we have vendors who will do both, or you think it's always going to be very different technologies, and they're just going to be vendors for batch and vendors for real time? They're going to be separate, and
there's always going to be a few vendors who are going to claim that they can do everything, right? So that's not going away. So there will be a select few vendors who will have an offering across all of these, but
silver bullet.
Really, what you want is the user, the consumer, to make the decision of which vendor, and what I really like about DBT is it sort of democratizes this whole ecosystem where it's a standardized way of expressing these transforms. So you really do have some level of portability between vendors. You can say, well, we're moving from today, for instance, a lot of warehouse A to warehouse B migrations happen using DBT. First you codify all your existing pipelines in DBT, and then you start trying to migrate to a different warehouse, right? And similarly, we all of the different modalities, the speed modality, maybe there's others that I'm missing. It's, outside of my wheelhouse, that also DBT is a sort of common expression framework.
This is really an exciting change that's happening in the space. And obviously it's going to take time, right? But I think at least what's clear with this conversation to the three of us is how we're finally getting closer to that world where you can worry a little less about the technology, even though, I hesitate to say that because we're all technology companies here, right, Billy? But worry a little less about the technology. And instead you're just like, well, how much money do I have, right? What am I trying to do? And, what time frame do I want it? Right. And
that's exactly right. That's exactly where I want to go. I often say streaming's an implementation detail, right? Like if we really solve the problem at Materialize, most of our users should not even know about streaming, right? They should just be like, this SQL fast.
Right.
SQL go fast.
Yeah.
And it happens, and they don't need to know anything about a modern scale out, shared nothing. And I think, going back to Cloudera Hortonworks, you brought him up. I think that was the problem with Cloudera Hortonworks. It was like, you can move to the cloud, but let's teach you all this stuff. And then Snowflake rolled around being like, to the cloud, SQL. Like, it's SQL in the cloud. And like, we see which pitch works better, right?
Yeah.
Like, what did the people actually want? They wanted scalability.
this is a learning. This is computer science, right? I always say computer science is about like this understanding what level of abstraction you basically focus your career on, and also you can be a compiler, right? I focus on working between these two things and how to go move, right? That's how computer scientists, technologists, I think we should be. And also the systems themselves are like that, right? You buy a system that does a particular layer of abstraction, another one that does a compiler, and then you get an expert between that. And I think a lot of the time, because we're focused on I'm a technologist on this layer of abstraction, which is lower, I'm trying to go sell that when it's like, no, we should actually go increase the level of abstraction. But sometimes we go too high up, and we go all the way high up, and we go to the low code, no code stuff, and it goes all the way. So anyway, this is my takeaway here is that, and I love how we're kind of closing this up because told you 45 minutes we've been chatting. We can keep chatting for hours more, but I love how you just said right now that it's an implementation detail. We should get a higher level of abstraction, and that level of abstraction should be SQL. I think we'd argue that it should be something that this is something we all know. It is declarative, which is the beauty of this. And hey, I want fast SQL. That's what I want.
That's exactly right. I love the framing you gave of like, there's some hard problems where like your compilers, right? You're trying to take something from a layer of abstraction and send it to one lower. And compilers are often, this black hole for computer scientists, right? It's just like how many of our friends have we lost to compiler engineering? Right? They're never coming back. They're gone forever. And people love to, and of course at Materialize we have lots of people who love the nitty gritties of taking SQL and creating an optimized query plan that expresses an optimal data flow. And obviously these people need to exist, and it's great that they love that, but the user does not need to care is a very critical, like a successful abstraction is one where people can live above you and they don't even know that there's something below.
So that's a problem, that when you work in that compiler, like, oh, people don't know about me and I feel sad, right?
You're the magic.
That's victory. That's victory.
That's something I was saying. I mean, my PhD was about compiling graph to relational, all that stuff. So I'm a compiler type of guy. Anyways, we got to go to our lightning round.
Just before you move on, I want to give a shout out to the LinkedIn user who just chimed in with a comment saying, "What floor of the abstraction tower do you work on?" I love that. That's a great question. And for some of us, I say, "Hey, I just want to work at the whiteboard. Can I just do that? That'll be my layer."
So if you care about the implementation details of taking SQL and making it sort of streaming, please come work with us at Materialize. We're hiring. So that's my salesy pitch, the one I'm allowed. Like, come hang out. That's what we care about. But our users should never care. Like, they should just live the SQL penthouse.
All right. Well, we're taking a little break here on the salesy thing. And I'll say, Data.world, we're also hiring. And I guess everybody in the world is hiring right now. But all right. So lightning round. Let's move to our lightning round, which is presented by Data.world. So I'll go with the first one. Will frameworks like dbt make it easier to migrate workloads from batch to streaming and back again?
Absolutely. Yes. I think we already answered this earlier. Like 100%.
Awesome. That's great. All right. Next question. Are the technical folks at companies the big drivers of the streaming infrastructure investments, or is it more the business side that's pulling it?
Today, a lot of existing streaming is driven by the technical, because it's so hard and it's so technically complex that they have to be the ones. But if you reframe that question as like, who cares about real time? You'll have a lot of business users who are like, oh, absolutely, this thing needs to be real time. And really the goal of Materialize is to up-level that conversation there.
That makes sense.
All right. You mentioned 20% of use cases may be truly real-time centric. I know you kind of hand waving that number 20%. Do you see that percentage growing over time?
Yes. I think as we show that real-time has a lot of value, particularly in the ROI increasing use cases, right? So then you'll see a lot more effort going into identifying and doing more analysis, more analytics to do more. So take, fraud detection, which, just for say an e-commerce or payments company, this will This is a multiplier on your business, right? You reduce fraud by 1%, and the business value goes up.
That makes sense. The more people see the ROI and maybe become comfortable with this easier paradigm, things are going to shift, right? Like you think like reverse ETL, right? Like that wasn't. I mean, it's not super novel. I mean, obviously it's a little clever, right? But like it's. I mean, that idea has been around, right? But like wrapping it with this easier user experience has suddenly really popularized it, right? Um,
Exactly.
and then, okay, final lightning round question here. Will streaming databases eventually become more popular than the streaming message bus?
Oh, that's interesting because you're always going to need to feed us with real time data, right? So maybe more popular than message buses are now, but the hope is that the whole party gets more valuable over time because the more you're doing in real time, the more you're going to need to move the data in real time. So I think it's sort of win-win for everybody, right? Like the
Hmm.
whole market. These are very complementary markets
That,
at the
that's
end
a
of the day.
very helpful answer because I think sometimes when people learn about Materialize or some of the the streaming database market, they're kind of like, oh, is this like this is replace kind of what I'm doing with Kafka and stuff like that. And it's good to know that these things they help each other, and if you're doing streaming use cases, you'll want more of both.
That's exactly right.
All right, Tim, take us away with your takeaways first.
Awesome. Well, this is our section where we take away what we've heard today from our awesome speaker, Arjun. So, really appreciate you joining today. So, I mean, so much goodness today. Obviously, we got to really dig into like what is streaming and what is streaming data and what does this mean for organizations. So, really, it's kind of the comparison with batch, right? Batch is more about the snapshots. It's more about the scheduled jobs and kind of bringing that work together in more of a grouped manner. And you brought up a little later in the conversation about a lot of times it has to do with like the performance constraints and things like that, right? Like you're bringing in all this information and you don't want to constantly be reindexing your database all the time. And there's a lot of use cases that don't necessarily require you to have that real time information. And so that's sort of that batch paradigm. But increasingly, we want to have real time uses with our data, whether it's for fraud detection or real time notifications or recommendations or things like I know like media and ad tech, and there's a lot of sort of various industries that need to do a lot around real time. And as you mentioned in the lightning round, that's growing and growing in its popularity. So these use cases are obviously really interesting and growing in popularity. And you went through the history of the space and how we've kind of got here. You talked about Tibco and the sort of the service buses and the complex event processing and some of the things where it started, and it moved to the big data realm. With things like like a Spark and that sort of thing. Kafka as the streaming paradigm, sort of changing the game with the sort of the infinite looping, background in terms of how much data it can hold. And then now with the new paradigm of streaming databases like Materialize is providing. So being able to see that evolution and how it's happened sort of, in parallel with the batch world, but very complementary to it is super interesting. And I think provides a lot of context to our listeners. So thank you for going through that. And
Thank you so much for having me.
yeah, absolutely. And Juan, I'll throw the ball over to you. What about you? What are your big takeaways?
So I three main things. One is the streaming with the modern data stack, right? And this was a very important takeaway for me. So you start with the modern data stack core. It generates the report, insights for users. A decision is made. And I need to make an action that needs to be automated. That's where streaming comes in.
Mm-hmm.
So that was an important takeaway that really helps me understand where it fits. Second, kind of the architecture, the shift that we will see, right? The E and the L will be move more into real time, right? It's already doing change data capture. Vendors will compete on latency going down. But then something I'm really, really happy to do, because the semantics is my life, is the whole idea of we need to have shared semantics, the meaning, the transforms that needs to be managed by encode and everything. And then that can be reused for batch, can be used for real time for streaming. And so that's how this whole thing all works together. But at the end of the day, streaming is just an implementation detail, right? Users should really don't care if it's streaming or batch, whatever. They just get the answers to the questions they want. They get fast SQL, fast query answering right there. So, Arjun, how did we do? Anything we missed?
Excellent. No, this was great.
All
Thank you
right.
so much for having me on the show.
So
I
we'll
really
throw it back
enjoyed
to you.
the conversation.
2 questions. Number 1, what's your advice about data, about life? And second, who should we invite next?
Ooh, I was gonna say Bob, but then turns out you're inviting Bob. You should have so I guess these answers are tied. You reminded me by you should have Spencer, the CEO of Cockroach, on the show. The I worked at Cockroach Labs, working on Cockroach DB before starting Materialize. And advice. This is tied to advice, which is find great people and mentors and go hang out with them. So when choosing a job or choosing, I think when I did my PhD in computer science, this was also the advice I got, which was you're not really choosing a topic, you're not really choosing a school, you're choosing an advisor, you're choosing a person, a human being who is going to teach you things. And I think Juan, I don't know how your experience was, but by the end of my PhD, I love my advisor. My advisor is my uh, sort of spiritual mentor in so many different dimensions. And Spencer at Cockroach, similarly, I joined Cockroach. It was about 20 people. It was very small. We built an OLTP database. I was there for uh, um, 2.5 years. It was a wonderful experience where I learned an incredible amount about building database companies, starting database projects, everything to do with the sort of 0 to 1 journey of a database. Mostly because of the generosity of the individuals who were so generous and forthcoming with their advice and also their money. And Spencer was the very first investor in Materialize. I remember telling him while I was still, he was ready to wire the money. And I was like, can I get off your payroll before you fund another database company? And so, yeah, it's all around the people.
I love that. And I'll take my advisor was same thing, was a father figure to me, and it changed my way. I am who I am thanks to a lot of people in life. And one of those very important is my PhD advisor. Started a company with him. That was Capsenta. That was a company we did a couple of years, which I sold and got acquired by Data.world. That's why I'm here. So yeah, be around people who make you better.
That's exactly right.
Arjun, thank you so much. This was a fantastic conversation. I learned so much. I've been wanting to go spend time learning about this, reading, and I'm glad we had this conversation today. Just quick reminder, next week we have Patricia Thane. She's a CEO of Private AI, and we're going to talk about sensitive data, another topic we haven't had much conversation about. So that's next week. Arjun, thank you so much. And thanks to Data.world always for supporting Catalog Cocktails. This is what I get to do on Wednesdays at 4 p.m. Not bad.
Thank you very much, Juan, Tim.
Cheers.
Great conversation. Tim, you've not been doing enough drinking, so
I'm going to work on this. This is my task now. All right. Have a great Wednesday, everyone.